Hi, I'm Cissa, and this is Jotai, an automatic benchmark generator. The name Jotai refers to a magic lantern, and the idea here is to bring programs to life. Jotai receives as an input a program that is compilable, but it has no main and no inputs. Jotai transforms this program by generating valid inputs and making it executable, so the program becomes alive. Executable benchmarks are important in the context of predictive compilation. I can train a predictive compiler with a large set of benchmarks, and it will determine for each program what's the best sequence of analysis and optimizations to apply. Given a new program, the compiler will know the best way to deal with this new code. But how can I generate valid inputs automatically? Let's say I have function sum that receives a pointer to integer v and an integer n, and it sets the member data of struct s to the sum of the first n elements of v. In this case, data will be set to 6, and we have no issues. But what if I change n to 6? We're going to access memory that was not allocated, and this is an example of undefined behavior. When generating inputs to functions, Jotai needs to filter out programs like this. So let's go to our step-by-step. As an input to Jotai, we need programs that are only composed of functions, like the function sum that we saw. For this project, the bases of benchmarks were extracted from the undefined repository that has over 1 million C programs. Once we have our programs, we need to know the type of inputs that we need to generate. The function signature and the struct members are extracted from each program and written in what we call a descriptor file. The information in the descriptor is used to generate constraints over the inputs. We write constraints with the constraint generator language. Constraints can be set over the value and the length of the inputs using different operators. For function sum, I can set n to 4 and the length of v to 3, for example. Or I can set n to a value that is greater than 0 and the length of v equals to whatever n is set to. Then, Jotai takes each constraint that was created and initializes the inputs according to it. For the first constraint, this is the code that we get. All the inputs are initialized as expected. Function sum is called with these inputs, and we feed the memory that was allocated. Every code generated for a constraint is going to become a case in a switch statement, and we bring everything together into a single benchmark. Here we have the first constraint that was generated as case 0. Then we have case 1, which is the other constraint that we created. The switch statement is inside the main. Then we place the original program. Finally, we add some includes and some auxiliary functions. And this is what the first version of the benchmark looks like. Now we must remove the cases that run with undefined behavior. We compile each benchmark with Clang's address sanitizer. After compiling the benchmark, we run each case. When we run the first constraint, we get an undefined behavior, since we try to access the fourth position of an array of size 3. The second constraint executes without any issues. The last step is to remove the cases that didn't pass. As you can see here, now case 0 is actually the second constraint, and the first constraint was filtered out. This final benchmark is going to be added to Jotai's collection. And this is Jotai. Now that you understand how Jotai works, let me show you how to run it. Jotai's tool and the benchmarks generated so far can be found at the repository Jotai Benchmarks. You can find a set of about 35,000 benchmarks generated inside the benchmarks folder, and the data we collected with cf2grind inside the data directory. This will give you information on the number of static and dynamic instructions for each constraint and optimization flag for each program. If you want to run Jotai, there are 2 ways you can do it. You can choose to build Jotai from source, or you can use the Docker that we made available. I won't go over the steps on how to build Jotai, but I'll give you an overall idea. So if you choose to build the tool yourself, you will start from the source folder. There you have Jotai and Jotai. Jotai is the code generator, and Jotai is a Python script responsible for calling Jotai commands and setting up the final benchmarks. First, you need to build Jotai. You'll find all the steps needed in the README in the repository. You will need LLVM installed to complete this step. Next, you have to set up Jotai. The dependencies are Python 3.10, Valgrind 3.17 compiled with CFG-grind, a working build of Jotai, and Clang. You'll also find all the instructions in the README for Jotai. Once you're done building Jotai and setting up Jotai, running the tool will work the same as running from the Docker, which I'll go over now. For the next steps, I'm assuming you already have Docker installed in your machine, but if you don't, you can take a look at Docker's website on how to install it. So after cloning Jotai's repository, you go inside the Docker directory and write this command. This might take some time to finish. After executing the command above, you can access the container in your machine with the command docker run it jotai. Now that we're inside the Docker, we'll be inside Jotai's directory, and we are ready to run it. But before I run it, I need to choose the folder with the programs that will be passed as an input to Jotai. That means the programs containing functions that we are generating inputs to. Inside Jotai, we've already set up an examples folder. If we check up this folder, we have 12 such programs from the undefined repository. Going back to Jotai's root, we can now run the tool. When running Jotai, I can pass h as an argument to get some help on how to actually run it. So I get all the options that you can pass to Jotai. Argument I is the only one that is mandatory, which is the directory with the programs, in our case, the examples folder. Next, we have J and capital J, which are the number of processes and a chunk size, but I'll just leave them to default. Then we have capital K, which is where you list the name of the constraints that you want to apply. Jotai can generate 7 different constraints, which are listed on the right. If I want to run all of them, I can just write all, like I'm doing down here. Then you can specify the optimization flags that you want to use to compile your benchmarks with argument O. If you don't add anything, the default is all of them. I'll compile the programs with O0 and O2. If you want to write the number of static and dynamic instructions collected with CFG-grind as a comment in the generated program, you can just add the S argument. And if you want to add runtime routines, you just add the T argument. Then we have argument C, which will clean all the benchmark generated and leave just the original programs in the folder that is passed as an input. Then you can choose to have a log file to take notes on what's going on each step of the process in case you get an error, but I'll also leave these ones out. So this is the command I'm using to run the tool. So Jotai will call upon Jotai to generate the inputs, and after Jotai is done running, which might take some time, a message should be displayed with the number of benchmarks achieved that can execute without undefined behavior, as well as the number for each constraint. Once we're done running, we can check our results. If we go back to our examples folder with the original programs, there will be a new folder with a D extension named after each program inside the input directory. Inside this folder, you'll be able to check the step-by-step of the process in case all of them succeeded. If I go inside the first one, I can see the descriptor file for the function and the constraint files that were generated. Then we have 2 C programs. The first one is the intermediate step that might contain cases with undefined behavior. And the one that ends with the final is our final benchmark that can run without undefined behavior. You can also find the binaries and the CFG files created during the process for each constraint and optimization. Now going back to Jotai, you also find some useful information inside the output folder. There you'll find a data set mapping constraints to their output value, in case they have one, and mapping each constraint to its corresponding switch number in that program. Finally, the CFG-grind results with dynamic and static instructions count can be found inside the folder util output. And that's how you run Jotai. If you have any questions, feel free to contact us. Thank you.